This time on Captain Chaos's laboratory, we are working on the Lemax Nativity scene. It has animals and characters that go on this track and on these different platforms. You got Jesus, Mary, and Joseph. Joseph was broken off of the thing when I pulled it out of the box, so we'll have to glue him back on. So at the moment we just have Jesus and Mary. This is one of the 9-volt units. And the 9-volt units, just like the 6-volt units, use a smaller barrel jack, just in case you haven't noticed before. So you can't screw up and put the 4.5 volts in there and run it at half power. But if you had a 6-volt one, you plug a 9-volt one into it, you're going to let the magic smoke out, and it's not going to work anymore. So make sure you watch your power supplies. So we turn it on. Music, lights, no motion. But I can hear it. It's trying. I'm thinking either... It sounds like the pulley's spinning really fast, so I'm thinking the belt broke. Could be the belt, could be a gear, but I can hear the motor spinning, and if the motor was shorted out, most likely we wouldn't have the lights and or music. So, let's see what it takes to fix this. Now on this one, the star is very, very brittle. Also, if you didn't know this, if you don't have this one, I have a parts one, matter of fact. That's how I found this out. The star rises. This is so cool. It's just like the moon that they came out with, where the moon actually could extend. So, most people don't know that, because nobody reads the paperwork, and we just want it working. We just want to set it up and let it go. So, that star rises really high, just like the moon does. So, let's see, is that going to be thick enough to help? There we go. So on the bottom we have 1, 2, 3, 4, 5, 6, 7, 8 screws in the dead center. We also have 4 rubber feet. I'll try and flip her over like that. It is missing a screw right there. I'm going to check if there's anything under the feet real fast. I don't think there is on this one. I don't remember seeing it on my parts piece. No. So it's just feet. This is a very unbalanced piece as far as weight goes. So it wants to roll around. So let's take out the 7 remaining screws. And I should have some spare screws that'll fit in here to replace at least the one that's missing. Yeah, I think I got this over at a Goodwill. It was the platform. It didn't have the 3 characters or any of the characters, as a matter of fact, even the ones that go on the rotating wheel. But I didn't buy it because it's the nativity scene. I bought it because it's parts for Lemax. It has the track, it has the gears, it has the rising star, which I know where the star is. I don't know where the rest of it disappeared to. But yeah, I think this whole thing at Goodwill was like, I don't know, 10 bucks. I figure for 10 bucks I'll have a stepped platform that I could redo into a Halloween style. And if I wanted to make the track work, I could. But I was looking more at breaking the top off and using the stones for a spooky display. But I honestly don't know where I put it, so I guess it doesn't matter. Alright, all the screws are out. And here we go. So there's one Molex connector that connects the top. And there's the screws. This thing's big, so it takes up a lot of space. Here's the track with the big gear ring. And then here is the top. So what I was going to do is, because this was partially broken off, is I was just going to repaint this a little bit to make it more spooky, get rid of the yellow for the hay, as an example, and kind of make it a cemetery scene. But I don't remember where I have placed it. There's the big track, and No, this one uses a synchronous motor. Probably helps if I plug it back in. So it might be a bad synchronous motor. Yep. The internals of the motor are gone. The internals are broke. It is a D-shaped gear, or shaft. Probably a good thing right now if I knew where it was to pop the motor out. We have a hole right here, which means that the pin that probably held this gear on, in this gear cluster, probably sheared. That's why it doesn't turn. I'm assuming this motor is going to be between 9 and 12 volts. We'll find out in just a moment when I unscrew it, so we can read the side. We have an 8 ohm half-watt speaker. It's one of the more higher quality ones. It's not the flat piezo style. It actually has a real cone and it's much larger. I noticed most of the Christmas pieces from Lemax come with a higher quality speaker than the Halloween stuff, which is weird since they mostly are almost the same as far as sales go. You'd think they'd put the same quality on both. So it is an AC 9 volt TYC motor. It's a 50-60 hertz, 4 watt, 5 to 6 RPMs per minute, and it's a counterclockwise rotation. Well, just in case you didn't know this, 9 volt motors, they're pretty much impossible to find. They have pretty much gone by the wayside. It's not a standard voltage anymore for hobbies, so everything's 12 volts. So this is a 12 volt with a center screw. Let's see if I can get the screw out. This one came with a damaged screw from the manufacturer, probably so you can't change the gear. Let's see what else I got. Apparently I had a little motor on top of that one. This one is 11 volts AC with a pressed on gear. So what they do is they push the gear on and they peen the top over so you can't pull the gear off. But it's 11 volts AC, which is closer to the 9. And then we have a 100 volt AC. This is for those like Chinese ones that don't have a transformer. The ones that on one of my videos I said they're very dangerous, be careful. Not dangerous because of poor quality, they're dangerous because it's 120 volts out of your wall socket, and it makes for a hair-raising experience. And then we got another 12 volt. This one has a double square shaft, and it's much, much taller. Might have to order this motor or something similar. I think that's all my motors, except for the one that hit the floor, which was a small motor. It wasn't a big one. Let's see. Got a 240 volt synchronous motor, and I got a 90 volt. Those are way too high. I got a lot of motors. Oh, let's check this box. Nope. Those are standard motors. Well, let me check my parts boxes that I have of parts houses and see if I have something that will work. I can try and repair this one, but repairing a synchronous motor is about a 50-50 chance. Just double checking to make sure I don't have another one on here. I think I got rid of it. I had a motor that I was using the internals for, and I think I finally threw it away or recycled it. So, yeah. bear with me for a second, and I will either come back with a motor, or I'll have to order one. All right, I'm back with the zebra stripes going through the screen because I still don't have that new camera. I went through my stuff, and surprisingly, right on top is the internals for this piece. Right there, look at that. There's the circuitry, and there's the OEM motor. So, I found the internals for this, but I have no idea where the rest of it went. That's pretty funny. I found the speaker too. So it was in my parts box. So that was pretty cool. It'll make life a little easier. So, snip. I'm going to assume the motor works. But you know what they say when you assume. So let's test it out. Now, this is a AC motor. I could turn on my Variac and plug this in and see if it actually turns. Which is probably a good idea, since if it's a bad motor, I don't want to blow the circuit board. Although if I do, I have a spare. I usually always recommend that when you, if you find pieces at a garage sale or Goodwill, what have you, and even if it's broken, keep it for parts. A lot of the pieces are interchangeable, and some of the pieces, like this older Nativity, use an obsolete motor, and if the motor's good, then you have a replacement. Let's see if I put my cord. It's right there. Using the AC power supply or the Variac to test high-powered stuff. So I have the high-powered stuff off to the side. So if I remember right, this should come up around 120 to 130 volts when I fire it up. And make sure it's not touching anything. 128 volts. Way too much for the motor. That's how you let the smoke out. So let's power that down. There we go. A little over 9 volts. So I will, it's AC, so it doesn't matter which wire goes where. I'm going to pop one wire in here. Click. And then I'm going to touch the other wire. Look at that, it spins. It's jerking because it's arcing. There we go. Okay. Pretty cool, huh? Alrighty. Turn off the power supply. Stop holding with my finger. For some reason, the AC is a lot more tingly than the DC when I hold it for low voltages. So now if you have this piece and you don't have a part motor, when you look up a synchronous motor, you can try and match the actual part numbers written on the back. They're usually pretty good at putting a part number. This one is a TYC 50, which means it's a 50 millimeter in diameter barrel. This one's part number is this long number here. It's 11 volts AC. This one came from American Science and Surplus. I bought it because of the 9 volt issues, but what I didn't know is they have pressed on gears, which kind of poses a problem when you're trying to, you know, work on stuff. So, but anyhow, the closest you're going to find is going to be 11. They do make a 6. I would not recommend getting the 6 because you're going to be overdriving it, which is going to prematurely wear out the motor. The 3 volt variance is actually quite a bit, and we definitely don't want to do that. Yeah, I am going to heat shrink and solder the new motor in. So let's grab some heat shrink. That's way too big. There we go. Smaller heat shrink. Same color. And for those of you who don't know, that if you don't have a Goodwill near you, Goodwill has an auction site, and you can buy, well, pretty much anything on it. And I have bought pieces off of there, even if they say they're broken, because again, you can try and fix them, or parts. Lemax doesn't have a parts section. They basically just want you to throw it away and replace it with something newer that you buy from them, so they make more money. Turn on the soldering iron. Because this motor is tin and that one was copper, to help ensure a decent solder joint, I'm going to put a little flux on them. You don't have to, just helps a little. And you can do it after or before you twist it. I'm only doing it before I twist it, so that way when I twist it together, the flux will be in between the twist. So we'll solder that one. The reason I say you can or don't have to do the flux is because most of the solder, if you get lead solder, has a flux core, which is what this stuff is. And it'll help with the penetration of the heat. But I find that tin doesn't like to solder as fast, so that's why I add a little flux. I just realized I hope the wire is long enough. Click. So let's check. Yes. Make sure you always check your wire length. I just realized I cut it short. So now let's slide the heat shrink up. Now if you don't know how to solder, you don't have a soldering iron, and you don't have anybody that can solder for you, you can just twist the wires together really tight and then slide some heat shrink on it. You can do hot glue, you can do tape, just something to hold them together and keep them from arcing against each other. So like on this one, the yellow shrunk. The tip of it shrunk because of the heat. So, of course the soldering iron is hot, so I'm going to use a little tape. And we're going to tape it. Before I do that, let's heat shrink the black one. I'm just going to do it really quick with a flame. So what happens is the heat travels down the wire, and sometimes if it's on there too long, the heat shrink will start to shrink at the tip. You can't just cut the tip off because it'll just start shredding the whole heat shrink. So I'm going to heat shrink the one and then just tape the other. And now we're going to put it back together. There's the parts for that. Alright, now if the motor is secured, meaning that it won't shift under its torque, let's plug it in and make sure it turns. There you go. Didn't turn the volume on. Wanted to turn the volume on to show you this still worked. I will try and link some synchronous motors below, and then when I reason I say try is it's a crapshoot. I've ordered synchronous motors that say they're 11 volts as an example, and it says it's a square shaft or a D shaft or a knot shaft or a short shaft or a long shaft, and then I get a message that says that's not available and they're going to send me something similar. Then I get a round shaft and I got to grind it, or it's too tall and I got to cut it. And in a few of the videos that I have up, you'll see where I've actually modified the shafts. Now, if the shaft has a screw or it's a long shaft like this one is a D shaft, but it's too high up as an example. I would cut this shaft down and then Dremel out the D to where the gear fit. But before you Dremel out the D, you want to drill a hole as center as possible, and that's the hard part, and then tap it, which is even more difficult. But you can also just make a D shaft that's a hair longer than this. So, and this is where skills come in. So if you don't have the ability to do so. So this D shaft is slightly too fat to fit in here. So you have two choices. You can grind this down to fit, or you can bore this out to fit. Either one. Personally, I'll grind this down before I bore this out because this is harder to replace than this. And then once it's short, make sure it's longer than the gear, and you can cut a groove into it with a Dremel. Just make a C groove, and you can put a spring clamp or a C clamp in there, a C clip. And that'll keep it secured so the gear doesn't walk up. So there are alternatives to fixing things when there are no parts available. So all 4 screws are in. Wires are short enough they're not going to get in the way of anything. So I'll put the track in, and there's the volume. There we go. Now I think, because the one I got, this was in the back. If you notice when I took this apart, it sat this way, which was in the front, and I don't think that's right. I think this was put on. I think somebody tried to fix it, which is fine. I always recommend you try and fix your own stuff, because you won't learn unless you try, and that's how you learn new skills. But if it's like mine, it should go in this way. I just got to make sure that the coil of the wire stays away from the gear, because the one I picked up as a parts house, that's how it sat. The star and the back of the manger was against the power in the back. And I believe that's what it shows on the box. Yes, it does, since the box is to my left or right. So I don't even know my own directions anymore. Now I just gotta make sure we line up the screw holes so I can start putting this thing back together. So. Now, I don't do Christmas villages, which if you're a regular channel watcher, making sure it's screwed in, it's actually screwed in. But there are things on the Christmas stuff, or the Americana series, so on and so forth, the different series that I do appreciate. And what I liked about this piece, besides spare parts, is like I said, the star. I actually have the star so I can try and incorporate it in my village, because I would try and change the color of it, maybe to red, or have it as an RGB where it changes colors on its own. I don't know. I know I took it out and I kept the star, and like I said, I kept the rocks to make them more spooky, but I don't know where I put them. And I think I know why I was missing that one screw, because the one screw that I just tried to put in, the second one, not the third one, this is the fourth, doesn't want to go in. I think maybe the screw sheared off inside of its hole, so the broken bottom piece of the screw is still in there. Because, yeah, this screw does not want to go in at all. And I don't really feel like taking it apart to look, and it's not really going to hurt it too much. 7 of the 8 screws is fine. I see people drive around the street with 5 lug nuts on their car, and it's supposed to have 8. So, and that's more scary than this. But I think the head popped off, and it broke off inside. Screws. And last one. Just torque down the first one and the second one, since they're now sticking out, since the rest of them have pulled the platform down. Let's get rid of that. And a random gear. I don't feel like taking the box apart and removing the 97 pieces that go on this thing. Go. Let that harden. Make sure it's all the way into its little piece right there. Lights on, lights on, lights on, lights on, lights on. Light, light, light. Let's turn off some lights and see how much illumination it has. Again, not going to pull out all the pieces, so we're just going to see the stones lit up in my rotating screwdriver. So there's your illumination, so you can see Mary, Joseph, and baby Jesus really well. You can see, you'll get a shadow down as well as the lights illuminating up of the animals that you're supposed to put here on the stones. And there's not a lot of illumination around the track, so as they cross in front, you'll just basically see shadows. Go. So that concludes. Let's kill some noise here. Light's coming back too. That concludes on how to open this up and potentially fix it if it's a bad motor. And again, the reason I say potentially fix it is you might have a problem with getting the motor. But I will do what I can to put a similar motor in the description. It's going to probably be 11 or 12 volts, which means that at 9 volts power, it's going to spin slower. So as fast as these screwdrivers are going, you might be losing 10 to 25% of its speed, 25% being at 12 volts. So it would be a little bit slower than this. Unfortunately, on some things, it's noticeable. This would be noticeable because of the amount of stuff this thing has on it. But rotating is better than stationary, so even if it spins slower, at least you got some motion. You can, if you want to try, and open this up and rebuild it. There's a tab, a tab, a tab, and a tab you got to fold up, and then pry it open. Careful, it hurts your fingers. And then that one is missing. You can see there's got pin, 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 and a hole. And that's why it clacks and clunks when it's running. It's not, nothing is loose inside. It's probably because there's a big magnet in the middle. It's probably just stuck in place. So normally I would try and open and rebuild it, but since it's a parts one, we're just gonna go with the parts house because done in less than an hour. So anyway, that's how you open and again potentially repair the Lemax Nativity scene with a 12 volt, or excuse me, 9 volt synchronous motor, 9 volt power supply. Don't get it screwed up with the 6 volt. And how you can potentially take a 12 or 11 volt and modify the shaft. Of course, I'm showing you with my finger how to modify it without actually doing it. But some of the other synchronous motors I've done, I've actually ground them down. I don't do it on camera because it's deafening when you're grinding. So, but there are other videos out there showing you how to rebuild, repair, and try and make your synchronous motors work. So they're becoming, certain voltages are becoming obsolete. Not all of them, like 9 volt. And it's been replaced with an 11 or a 12. So it is what it is. We can only do what we can with what we got. So there you go. Nativity scene done. If you have this piece and you didn't know, star extends. If you don't have this piece and you didn't know, star extends. Other than that, you're good. Till the next one, thanks for watching.